Alright, so fluency today will be coming from our practice book. It is a sprint. Remember, sprints, you have 60 seconds while I'm explaining. If you're already like, I know this, make sure you get your Starry Night book with the yellow and the P. It's on page number 35. So getting my book, opening to page number 35. Here we go, 35. Yeah, getting settled. I have my pencil. I'm stalling so you can get your stuff together. We start at the top. We work our way down. We go back to the top. We work our way down. Our directions say count on to add. I am going to put 60 seconds on the clock because this is a sprint. You're going to do your best, and you're only working for or with yourself. It's only to compete with yourself. Try to better than you did last time, or better than we'll do next time you did. I don't know how you're watching these things. Okay, on your mark, get set, go. What you're doing. Stop what you're doing. Okay, so we're going to check our work. Come on. Okay, here we go. Remember, we were counting on to add. We're going to start with number 1 and work our way down. 2, 3, 4, 5, 4, 5, 4, 3, 4, 5, 7, 8, 7, 8, 9. All right, on to the top of column 2. Question number 16 is 7, 6, 7, 7, 6, 6, 7, 7, 8, 9, 9, 9, 10, 10, 9. Great job. Remember, you were checking as you went. Count up the number you had correct and write that number in the starburst at the top. Yay! Good job, guys. All right, put away your fluency book, your practice book. Get out your learn book with this lovely meadows. It's time for today's application problem, which is on page number 129. 129. Apparently, was talking about Dylan and his pets again. Alright, so yes, our application problem, and like I said, Dylan is back. It again is on page number 129 in your Learn book. That's the blue. Notice I made my. Did you notice that I made my numbers match the book you're gonna get? I thought it might help. If it's not, let me know. Alright, so I'm gonna read it. You're gonna work it, and then we'll work together. Dylan has 4 cats and 2 dogs at home. I know we found that out yesterday, but today he's not hanging out with Laura. He's hanging out with Sammy. And Sammy has 1 mama bunny and 6 baby bunnies at home. Draw a number bond showing the total number of pets of each household. So just like yesterday, where I had you set up your page, I'm going to do it with you. Had you set up your page? It's the wrong book. It helped I had it book. We're going to set up our page again. This time we're looking at not dropping our things. Dylan and Sammy. And again, Dylan, pets, Sammy's pets. We're trying to find out if they are equal. Understand? So that is your setup. Pause if you need a moment. That's your setup. Okay, good. So that's your setup again, and I'm going to read it one more time, and then you're going to pause just so you can work on it. Dylan has 4 cats and 2 dogs at home. Sammy has 1 mama bunny and 6 baby bunnies at home. Draw a number bond showing the total number of pets of each household. Write a statement to tell if the 2 households have an equal number of pets. An equal number of pets. We want to know if they're equal. Alright, so now we're back together and we're going to do on the board exactly what we did in our book, and that was D for Dylan, S for Sammy, are they equal? Let's find out. So Dylan still has 4 cats and 2 dogs, which the other day we found out was 6 pets. Dylan has 6 pets. Let's check out Sammy's. Sammy has 1 mama bunny and 6 baby bunnies. While they're all bunnies, they put them into 2 groups. 1 being the mama and 6 being the babies. So how many does Sammy have? Well, 6 babies, 1 mama. 6, 7. She has 7 pets. So let's write that number sentence and see if it is true. Is 4 plus 2 equal to 1 plus 6? Check out your holes. They don't match. Sammy has more pets, but Sammy has more pets. Does that answer the question we were asked today? Maybe. Let's look at the back in here. Let's see. Write a statement to tell if the 2 households have an equal number of pets. So our directions are to write a statement to tell if they have an equal. And the answer to that question is no. They do not equal. Sentence. Bam. No, they do not equal. And that is kind of going to set us up for what we're looking into today. Today, instead of looking at different ways to make the same whole, we're going to look at different number sentences created from the same number bond, different addition sentences. I have some fancy math words for you. It is called the commutative property of addition. The commutative property of addition. All it means is the same way we saw her 1 bunny and 6 bunnies, but we added 6 plus 1 and we'll get the same 7. That's what commutative property of addition means. Look at your fancy scholars. I see you. Okay, so tell me in this picture, how many boys do you see? And how many girls do you see? Okay, correct. We have 1, 2, 3 boys and 1, 2, 3, 4, 5 girls. 5 girls. We're creating a number bond. So one part is 3, the other part is 5. When we bring them together, we get a whole that is what? 8, correct. Now, let's write that in our number bond setup, okay? We've established our whole to be 8. We see our 3 boys and our 5 girls. Can we write a number sentence to match this number bond? We can. We can say 3 boys plus 5 girls equals 8 children. But is that the only number sentence, the only addition sentence that we get from this number bond? No. We could also say girls and then boys. We could say 5 girls plus 3 boys still equals 8 children. And that's what the commutative property of addition literally means. It means I can add this group to this group or this group to this group. My groups stay the same size, and when I put them together, I get the same whole. It's a rule that lets us put the bigger number in our head, no matter where it is, and count on. Or when it's time to get into bigger numbers, you'll understand why you want to be able to pick and choose which part or add-in you want to use first. Let's try some more problems. Clears over here. Alright, this time we have little piggies. And I got these little piggies out of your homework book, the one that says Succeed with the red. It is page number 82 in your homework book. So, the homework book. I'm looking at the numbers. And turn to page number, sorry, 81 specifically. 81 is that front side. Page number 81, you'll see there's those same little piggies. If parents, you still need some more helping your student, there's what's called a homework helper directly in front of it, and that'll help provide you more direction as to what we're doing if the video is not sufficient enough, and if you can't get in contact with me. Granted, not getting in contact with me is kind of, the odds of that are slim. So let me know if you have any questions. Okay, so this picture we have baby piggies and big piggies. So let's figure out what are our groups, our parts, and our whole. How many big pigs are there? Correct. There are 2 adult pigs. And how many little piglets are there? 5 piglets. Good job. Let's count all to find our whole. 1, 2, 3, 4, 5, 6, 7. Our whole is 7. And from this number bond, from this picture, we have at least 2 options. We can say parents plus piglets equals 7 pigs. We can say piglets plus parents equals 7 pigs. They are both correct. And that is, like as I was saying, what it means to switch your parts and put them together. As long as you keep the value of the parts the same, your whole will stay the same if you're trying to operate within the same number bond. Let's do a couple more examples before I give you your assignment. These also come from the Succeed homework book. It's on the next page. This one is actually 83. See, I forgot they didn't write on the back side, so that's my fault. This is 83. So here we have, as you see, we have 8 as our whole and 5 and 3 as our parts, which means there are at least 2 number sentences we can write. We can start with 5 as our first part plus 3 as our second part, and that gives us our whole of 8. Or we still have the power to start with 3 and then add the 5, and it is still equal to 8. That is still our whole. Looking at our next number bond, what's missing? Great job, you're right. The whole is missing. The whole is missing. So we can start with 8 and 2 is equal to, what is that whole? Let's count on. 8, 9, 10. So our whole we've discovered to be 10, putting 2 parts together. So 8 plus 2 is equal to 10, but that means 2 plus 8 is also equal to 10. Because both numbers come from the same number bond. Let's look at the last one here. The last one here, what is missing? One of the parts. Excellent. So we know that 5 plus is equal to 7. So in this instance, we will again count on to find the missing part. So we'll put the part we know in our head, and we will count on to our whole. 5, 6, 7. What was missing? 2. Great job. So 2 is the missing part. Well, it's not missing anymore. We know that 5 plus 2 equals 7. So if 5 plus 2 equals 7, then we also know that 2 plus 5 is equal to 7. And that, my friends, is called the commutative property of addition, and that's what happens when you write different number sentences using the same number bond. This one number bond gives you at least 2 addition sentences, and that's true for all of your number bonds. Hold up, why did we stop there? Oh no, we need some more information. Like I said, we need some more information. So we left off right here with our 3 number bonds and our 2 addition sentences apiece. And yes, this is the commutative property of addition, but we're not done yet. So if for this number bond here, we see 5 and 3 are our parts and our whole is 8. Well, we've already talked about this. We can actually start with the whole. So in addition to 5 plus 3 equals 8, we know that 8 is equal to 5 plus 3. And along with 3 plus 5 equals 8, we know that 8 is equal to 3 plus 5. See? So for each number bond, there are 4 possible, these are the and more, 4 possible addition sentences, because we can put, as long as our equal sign is used to represent balance or matching, you can have whole equals part plus part, or you can have part plus part is equal to whole. Let's do the same thing for this 8 and 2, a way to make 10 number bond. So if 8 plus 2 is equal to 10, then 10 is the same as 8 plus 2. It's just a matter of putting the pieces as a whole at the beginning and then break it into parts. So we can start with our whole and break it into parts, or we can start with part and make a whole. So we have one more number sentence here, and that is 10 is equal to 2 plus 8. Okay, and lastly, of our number bond, 2 and 5 creates a whole of 7. We know that part plus part equals whole. 5 plus 2 equals 7. Part plus part equals whole. 2 plus 5 equals 7. We also know that whole equals part plus part. Whole 7 equals 5 plus 2. And the last one is whole equals part plus part. 7 equals 2 plus 5. Okay, now, as we work. Alright, so now, what are you supposed to do? Your problem set, the problem set in your Learn book, just like every day. It's found on page 131 in your Learn book, the same place we do our application problem. And when you're done, and you spend 10 minutes working on it, like working on it, when you're done with that 10 minutes, then you will click on to the next slide, which is like, that little blue arrow button over here, which will allow you to access your exit ticket. And then from here, you will fill in your answer, you will hit submit and turn it in to me.